there. All right, today we're going to talk about arithmetic sequences, and it's kind of a follow-up from our previous lesson that was kind of a generic introduction to sequences. We're going to focus just on arithmetic sequences today. Let's talk about what that means. Arithmetic sequences are sequences where you can see the pattern is that you are just adding the same value over and over and over. So it would have to be that's what we call the common difference, that number that's being added over and over. So it wouldn't work to do +1, +2, +3, not like that. Like that number there is the same every time. And you can find that by taking a term and subtracting the previous term. And that would tell you what your common difference is. We use a D to notate that common difference. So here's what our rules would look like as we write them. If you're going to do a recursive rule, to find a particular term, you just look at the term before it and add your common difference. That's what a recursive rule would look like. Now, for this to work, I would have to know where to start. They would give me the first term, and I'd have to know what my common difference is. Let's look at an explicit rule. This is sometimes called the general term or general rule, or the nth term. I want to look at an example one first, and then we'll come up with this generic rule that we'll write right here. Okay, so if the first term is 4 and our common difference is 3, this is what we would do. If we were looking for the second term, you would just take 4 and you'd add 3. But if you were looking for the third term, you'd start at that 4, but you would have ended up adding 3 twice to get there. The fourth term, you would have had to add 3 3 times. The fifth term, add 3 4 times, and so forth. And so looking at that pattern, ultimately what we would have done is we would have taken 4 and we would have added 3. Now, how many times, though, would we be adding 3? Well, it varied depending on what term it is. So what I'm wondering is this 5 means I added it 4 times. This 4 means I added it 3 times. Do you see the pattern there? It's always 1 less than what term I want. And I want the nth term, so I'm going to take it times 3 in minus 1 times. All right, so that right there is how we'd write an explicit rule. But let's write a generic version, so it would be like this. The nth term is always going to be the first term plus your common difference in minus 1 times. All right, so I gave you a slide that has those two rules. That is for arithmetic sequences only. And just a little bit, I put the D in the front of this quantity because I think in my head I'm going to add something this many times. But what happens is when you write like the n minus 1, if this becomes a number, like a 24, that's why they put it in the front. It'd be like 24D. So either way, doesn't matter. Now, we're going to use this explicit rule inside and out, every which way. And this is the thing that we kind of made a deal that you have to show me your work using the explicit rule. This is not a thing, that chapter where we're going to do it in our head or just do it all in the calculator. You have to show me you know how to manipulate that explicit rule. So on this first example, I am looking for the 9th term. What they've given me is the first term and the 22nd term. And somehow I'm supposed to figure out what the 9th term is. So I'm going to use my explicit rule. The nth term would be the first term plus the common difference times n minus 1. All right, so let's fill in what we can. Well, I know that the first term is -4. I don't really know what I'm adding, so I'm going to leave that as a D. But what I could do is I could put in the 22nd term right here. I can't put in the 9th term. I don't have enough information. But if I put in the 22nd term, then I know that this would be a 22 minus 1. And now, well, the 22nd term is 164. Well, so I've got 164 minus equals a -4 plus something times 21. And we're just going to solve that then for D to see what the common difference is. So I'm going to add the 4. That'd be a 168 divided by the 21. The common difference is going to be 8 on this problem. Now, if that's 8, now I'm going to have enough information to be able to find that 9th term. That's what I originally was wanting. So this is great, but now I'm ready to go ahead and say, all right, the 9th term would equal the first term plus 8 n minus 1 times, so that would be 8 times. All right, so it looks like you have a -4 plus 64. Our 9th term is 60. All right, now that one actually was pretty nice because they handed me the first term. Look at this next example. And look at this. I'm looking for the 500th term. So definitely don't want to do a recursive situation. I want explicit. But what they're giving me is the 15th term and the 27th term. And I'm supposed to get to the 500th term. All right, now to do that, because now I don't have the first term and I don't have the common difference. And all I would have is I'm looking for the 500th term. So I know this will be a 499, but I'm missing these. So I have to come up with some sort of a way to know what one of those is. So this is sort of overwhelming. So just follow my pointer here. Don't look at all of this other stuff yet. All right, so the second term would be found by taking the first term and just adding your common difference. If you're looking for the third term, you would have the first term, but you would have added the d value twice. Or you could even write it like this. What if you wrote it as the third term in reference to the first or to the second term? Then if you knew the second term, you'd only have to add the d once to get it to the third term. All right, how about fourth term? How many ways can we do that? Well, if I start with the first term, then I'd have to add 3d. If I look at the second term, I'd only be adding 2d. If I looked at the third term, I'm adding 1d. And now you got the fifth, and so it's the same scenario, all these options. And what I'm looking for is some sort of connection between looking for the fifth term, using this as your initial, and how many times you have to add d. All of those numbers, there's got to be some sort of a pattern there. All right, hopefully you're seeing that it's really this value here minus this value gives you this value. It works on every 4 minus the 3 gets me the 1. 4 minus the 1 gets me the 3. Works every time. Okay, so that's going to help us then know, because I'm going to rewrite this, but I'm not going to write it in reference to the first term. I'm going to have to write it in reference to the 15th term, looking for the 27th term. So I'll put the 27th term here, the 15th term here, and now I'm going to know what to put here also. All right, let's go to the next page and do it. Okay, so it says determine the general term, which is the explicit rule, first. And we're going to use that to find our d and find our first term. And then we'll write the rule. So I already told you I'm going to have to use the 27th term here and use the 15th term here. And then I'm going to add my common difference. And I know I'm going to end up adding that common difference. Well, let's see how many times. 27 minus the 15. All right, that's 12 times. So I'm going to put a 12 right here. And we can go ahead and fill in the 27th term was 85. 15th term was 49 plus, and here I might just change that to a 12d. All right, subtract the 49, divide by 12, and you get a common difference of 3. All right, so now I'm going to do this again, but this time what I have to find is the first term. Now, I'm going to have to use one of the given terms. I'm probably going to use this one just because it's smaller. So I'm going to write another formula here, another explicit rule. So the 15th term would be the first term plus the common difference 14 times. But I know some stuff here. The 15th term is 49. And the common difference we found to be 3. So 3 times 14, that's 42. Subtracted to the other side, it looks like the first term is going to be a 7. Okay, now I'm able to write the rule, the explicit rule that they wanted. The nth term is always going to be the first term, which I now know, plus the common difference, which I now know, n minus 1 times. That's the explicit rule. Let's use it to find the 500th term. So to find the 500th term, I'm going to take 7 plus 3 times 499. All right, we got it. There it is. So one more time, I can't say it enough times. I would expect to see both of these in work. None of that, well, I just did it in my calculator. That didn't work for me. You got to show me some nice work. That was our deal. All right, we did a little discovery activity in class on Gauss, and he's a mathematician. Well, he was a famous mathematician, but at 10, he came up with this concept, this idea of adding all the numbers in an arithmetic sequence. So instead of listing them out with commas now, we're starting to add them up. That's with that summation notation. But on your homework, you only had to like add up 5 or 6 numbers. If it's a much longer sequence, that would be very tedious. So here is a formula to find the sum of an arithmetic sequence. So the capital S means sum of n terms. And I'm going to take the number of terms and divide it by 2. And it gets multiplied by the first term plus the last term. Now, this is a great little formula. Sometimes you get handed exactly what you want. Sometimes you got to use your explicit rule to figure out some missing parts. Let's try a few. This first one says expand the summation, and then we're going to find the sum. All right, so let's start with expanding the summation. What that means is just start listing the numbers out. If I plug a 5 in, that'd be 15 plus 5, so that's a 20, plus, now put a 6 in, that's 18, plus 5, that's a 23, plus, put a 4 in, I'm sorry, not a 4, put a 6 in, sorry, already did 6, put 7 in, that's 21, plus 5, that's a 26. All right, and then what I would do is I go plus, dot, 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 and then let's go ahead and put in the last term, plug 60 in. So that's going to end up being 185. So that's what it looks like to expand the summation. Make sure you have plus signs, not commas. Now, to find the sum, I'm going to use my formula. It's going to be the number of terms. Okay, so let's talk through this. How many terms are there going to be? It's not 60 because we didn't start off at 1. I did not use 1, 2, 3, or 4. So it's going to be 60 minus the 4 I didn't use. So that'd be a 56. So there's 56 divided by 2, first term plus the last term. All right, you can just type that in your calculator. I'm doing it real quick right now. All right, I got 5,740. Okay, now let's look at the next problem. It says find the sum of the first 35 terms of the arithmetic sequence, and they get it started for us. But we don't have everything we need. Now, to find the sum, we have to know how many terms there are, the n. So yes, I've got 35, so I've got the n. I have to know the first term. Yep, I've got the first term. I have to know the last term. I do not have the last term. And that is where our explicit rule is going to come into play. So the explicit rule would look like this. The first term is 8. It looks like we are adding 3, so plus 3, and then n minus 1 times. That right there, that's your explicit rule. Anytime you have to find the explicit rule, that's where it is. Now, I'm going to use my explicit rule to find the 35th term. So to find the 35th term, it's going to be 8 plus 3 times 34. And that gets me 110. So now I know what the last term is. It would be 110. I'm going to use my sum formula then. Take the number of terms, which there were going to be 35 terms, divide it by 2. first term, which is 8, plus last term, 110, and we multiply that out. It doesn't matter that that 35 over 2 ends up being a fraction because it's all going to play out in the end. I got a 2065. All right, last one. Kind of ties it all together here. We have a teaching position that has a starting salary of $45,000 and a raise of $2,000 every year. So let's write an expression for the nth term. That means write the explicit rule. So the nth term would equal the first term, which I know is 45,000, plus the common difference, which is the 2,000, times n minus 1. Okay, so there's your explicit rule. Now it wants me to write the summation notation to show the total income for a 30-year career. All right, so that looks like this, the summation notation. I'm going to let my n start off at 1, and I'll play with that if I need to. And I know I'm going to go for 30 years, so I know I'm going to do 1 through 30 here. Now, the next thing you need is the function, and that really is the explicit function. So you could write 45,000 plus 2,000 n minus 1. And that's totally fine. You can leave it like that. It is a little bit messy to use because you could certainly simplify that up by distributing. So either write it like this, but I'm going to tell you that on your homework, actually I'm going to undo that. I'm not going to box it because I know on your homework, they're going to consider this unsimplified. So what they're going to want you to do is go ahead and clean it up. So that's going to be a 2,000 n minus 2,000 with this 45,000. That's going to be a 43,000 plus 2,000 n. Then we can always check it. If I plug 1 in, yep, I get the 45,000. Put 2 in, I'm going to be at 47,000. So I'm good. This is where you start, but clean it up before you submit it in my math lab. All right, next. It says find the total income for the employee after the 30 years. All right, so now what we're going to do is go ahead and use our sum formula. We're going to add up all these years of income. The number of terms would be 30 over 2. First term was 45,000. Last term, oh, I don't have the last term. I need to figure that out using my explicit rule. So the explicit rule up here, I'm going to go up here and do it. I want to know what the 30th term would be. So that's 45,000 plus 2,000 times 29. Okay. You already have the answer. This is what you get for waiting on me. I get a typo on my calculator, then I got to redo it. All right. So here's what I've got. 103,000 as the final. So this right here, this is being used right here. That's where that number is coming from. All right, so I'm going to put 103,000. All right, and now I'm going to just calculate this, add the 45,000, then take it times a 15. And I get for a year, not for a year, for a 30-year career, made $2,220,000. Well, that's bad. That's a 2 with a comma. Okay. All right. There we have it. All right. Go get your homework done. Good luck.